Hi and welcome back. Today I'm going to be building a small holdfast for the pritchel hole of my anvil. Now 10 or 20 years ago I would have said that the holdfast would have been pretty high up on the list of man's most forgotten tools, but they've really come a long way in the last few years. People are beginning to recognize what a simple and elegant solution they bring to the problem of clamping something to a workbench. And even though on the surface they may seem like an extremely simple tool, there are a few things that you need to understand about how they work before you can build a really good holdfast. Holdfasts come in one of two different shapes. The first one is just a simple bend in a bar, the ends flattened out. Not really a lot I can tell you about how to build this. You've seen it, you can figure it out just by looking at it. The one thing I do need to stress though is that holdfasts should be made out of spring steel. They don't have to be heat treated or tempered in any way. Just the inherent qualities of the steel will give it the performance you want. The second most common shape of holdfast is a little bit more traditional. It has a square corner, requires a lot more forging, and again the end is just flared out slightly or shaped in a pad, whatever you want. Now the interesting thing about these two holdfasts is that even though they're the same tool, they function very differently. This one, the corner is made to be inflexible, so the spring is actually the front half of the holdfast, and that is providing the pressure up against this part of the shaft that jams it inside the hole. With the other one, the whole corner is actually flexible, so the spring is starting right here going all the way around the corner, so this whole thing flexes and that pushes it over and jams it into the holes. With both of them, all the rules that apply for forging springs apply to these tools. You can't have any nicks in them or any marks or anything that might put a stress point on the spring. Everything has to be smooth and clean, otherwise you'll create a fracture there at some point when you're using the tool. To use the holdfast, you drive the top part of the holdfast down to clamp it. See, now I have a good pressure on this, and to release it you drive the back end. This unjams the post from the hole and the spring pops the holdfast up. Now holdfasts have a maximum pressure that they can apply. See, now I've applied this pressure, it's holding this plate, I can't move it. Hammering this down more is not going to apply more pressure, it's simply going to deform this tool. And this is where the mild steel really shows up as being weaker than the spring steel. I can actually force this quite a bit. The elasticity of this is going to give me a much wider working range than with the mild steel. So even though I've hammered this down a couple of times, I can release it and it's going to spring back to where it was before, whereas mild steel you're going to lose a little bit every time, and eventually you're going to find this arm flattening out and becoming less effective as you go on. The holdfast that I'm going to be demonstrating for you today is essentially a square corner holdfast like this one, only there's going to be a lot more material on the inside edge of this corner, and that square corner needs to be made a little bit differently than the one that I've demonstrated for you with the basic hammering videos. So that's what I'm going to show you today. The material that I'm going to be using for this holdfast is an old crowbar. I find the steel in crowbars to be fairly good, and I've used them for a lot of tools. Now the problem with upsetting spring steel is that you have to hammer it so much harder than you would mild steel, and since I'm going to be driving this straight back onto itself and I want to be able to hold it in the vise jaws just aren't going to be able to grab onto this steel and secure it enough so that I can hammer on the end to upset it. So what I've done is I've welded on a couple of lugs, and they'll push up against the side of the jaws when I clamp them in, so I'll be able to hammer pretty much as hard as I want to and get a good upset here without having to spend too many heats doing it, because I don't get the slide and the creep that you would get normally with upsetting in a vise. You'll notice when I start upsetting this bar that it begins to bend almost right away. This is quite normal for spring steel. It really resists any kind of deformation, and it's easier for it to bend than to try to push back on itself. I'm using the pair of tongs to try to control the bar as much as I can, but this process is just going to require a lot of straightening at the end of each heat. And heat 2, 3, and 4 is just more of the same. Upsetting, straightening, and then going back into the fire. With this heat, I place the lugs right in the middle of the heat, and then I'm not tightening down the vise very much. I thought I could just hammer the bar back and just naturally shear the lugs right off the bar as I'm upsetting, but that didn't work. Here I'm using the last bit of the heat to break the welds free on the lugs. This one gave me a fair amount of trouble. I must have learned to weld at some point. So a little bit of cleanup and I'll be right back. So there you have what we were after. This started off as a 14-inch bar. I've pushed it back to 12 inches, and the average heat was maybe 3 to 3.5 inches. So that's a lot of material that got pushed into this one little area. This is a 5/8 hex bar, and this is just under an inch in diameter. So there's a lot of material there, and that's what we're going to use to make this corner. Unlike a normal square corner where you bend the bar first and then you hammer the outside edges of the bar to make that square outside edge, with this type of square corner, the inside edge has to be shaped as you form this. So you need to have the material in place before you start. That's why we did it this way and went ahead and upset all that material before we started. So now what we're going to do is we're going to shape this back to 5/8 of an inch on one dimension, and then profile the outside edge of the corner, getting it ready for bending. So here's the corner joint all laid out. I started off by reducing the thickness of the bar down to 5/8 of an inch to match the original bar, and then I shoved everything over to one side because this is going to be the outside corner. So the shaping is all pretty much done right now. You can just start to see the outside edge of that corner right here. And that's what I was talking about earlier. When I needed the thickness before I started the bend, I needed this dimension here to be there before I start the bend, because that's going to be the final dimension of the corner. So now I just have to finish shaping the end of the holdfast, and then I'll be ready to start wrapping this joint around the mandrel to shape the inside edge of the joint. In this heat I'm doing two things. I'm starting off by creating an offset at the very end of the bar so I can section off a portion of metal that I'm going to need to cross peen into the pad foot of the holdfast. And then from that point back to the corner, I need to create a very smooth and gradual taper that will form the spring of the holdfast. You'll notice when you start bending this joint that you're going to get a lot of distortion. That's just natural because the heavier parts of the bar are going to resist bending more than the thinner parts of the bar. But what you do to correct it is you just hang the hook over the end of the mandrel and you hammer off the edge of the mandrel to
be able to straighten that bar back out. You do that from both sides, and that makes the joint as square as you can with this mandrel. The important thing with this heat is that you get the bars as straight as you can going into the corner, and that you have a nicely shaped radius on the inside edge of that corner. Okay, so that's the preliminary shaping of that joint. I still need to push a little bit more metal into the corner like you would a regular square corner. But that's okay. Now that that inside radius is defined, we should be able to do a bit of work on each side of that corner without losing that inside shape. Now when you're working the corner in the vise, the only thing you really have to be careful of is to make sure that you don't hammer from one direction more than the other. You have to make sure that you hammer both sides of this joint very evenly, and you occasionally go back to the mandrel to make sure that that inside corner stays nice and clean. A couple of heats and you're done. So here's a comparison of the two holdfasts. So you can see how the standard square corner leaves an inside corner that's sharp and square, whereas the extra material, when we upset it to begin with, gave me the extra material to put this nice inside radius on this curve. There isn't really any mechanical difference between this holdfast and this one. This is still a good square joint. It's solid, it's not flexible, so the spring is going to be all through here. I'm not going to be creating any stress fractures here because I have a weak spot in this corner. This is the heaviest part of the bar, and this spring will flex rather than this corner is going to flex. But this is more of an aesthetic look to it, and it does show a little bit more of expertise in terms of forging. So it's just one of those quiet ways to let people know that you know what you're doing. So there you have it, the holdfast. Now you can do your part in removing it from man's most forgotten tool list. We'll see you next time.